All right, so anyway, lungs, just Boyle's law. If the volume increases, that means the pressure decreases. All right, let's see. Let's look at the eye. The eye might be my favorite organ. Do you have a favorite organ? Did I ask y'all this? Y'all don't have a favorite, right? No? Okay, I think the eye might be my favorite. The eye or the ear. When we're talking about the eye, at least in terms of pressure, there are a couple different pressures. The intraocular pressure. The intraocular pressure, this is just the pressure of the fluid inside of the eye. We're going to talk a lot about the eye in a later chapter when we get into light and optics. But we're just going to sort of talk about the fluids here now. This is normally about 10 to 20 millimeters of mercury. So remember, this is about what the blood pressure is in the like in the vena cava, at the low pressure end of your systemic circuit. You can have a couple of medical problems with your eye. High pressure, if you have too much pressure, too much intraocular pressure. This is called glaucoma. And too low of a pressure, then you can just have a collapse of the eyeball. Because it's not a rigid structure, it's nothing holding out except for the pressure inside of it. So if it's too low, then it'll just collapse. There's several parts to the eye. You should know these parts. As I said, we'll get into it later, sort of how these parts function related to the optics of the eye. We have the cornea, which is just the outer surfaces. The aqueous humor. I'll show you a picture here in just a bit, just a second. Aqueous humor. This is a fluid in your eye that's replenished. So this fluid is replenished. So it's flushed out continually. It's replenished, and then it comes out of your eye as well. The lens will focus light onto the retina. And the vitreous humor is another fluid. This is what holds the eye's spherical shape. And this actually is not replenished. So what you have here is what you've had your whole life, vitreous humor. And then also the retina detects the light at the back of the eye. We'll talk about how that works later in a later chapter. See, I think there's a picture of this. Let me double check that. Oh, it doesn't look like they put a picture. I think I have a picture. Just a second. Yeah, here we go. So these are all those major parts. So here's the cornea. This is the aqueous humor. That's the part that's replenished. And the vitreous humor is the fluid that retains the shape of the eye, so it keeps the shape of the eye up. And then this is the retina. I think those are the only things. We'll talk about those other parts later in a later chapter when we do light. But just know those basic parts of the eye: the cornea, the aqueous humor, the vitreous humor, and the retina. Oh, and then also the lens, which is right here. All right. All right. Let's see. You can use a tonometer. Often if you go to the doctor, they'll want to know what that intraocular pressure is, so they use a tonometer. Tonometers can work in different ways. You can have a tonometer that will actually tap on your eyeball, and it'll measure basically how much pressure is required to move the surface of your eyeball, and then that can measure that intraocular pressure. Or other tonometers can sort of just like blow wind at your eye, and then they'll use that to measure the pressure in your eye. So a tonometer is used to measure the pressure in the eye. And it just really, the simplest one is it just taps on the eyeball and it measures the force required to bend the cornea. I'll bring a tonometer next time, and then we'll take volunteers and I'll measure your intraocular pressure. How's that sound? I have a video. This is actually a veterinarian video where they use a tonometer to measure the pressure on a beagle eye. It's kind of cool, actually. Can I play this? Take this away? Yeah, I'll come back to it. So our cornea is here on the outer surface. It's actually the whole outer surface, but usually when we talk about the cornea, we're just talking about this part. And then here's our lens, which is this fluid-filled sac, and it causes light to refract when it comes into the eye. So our aqueous humor is this fluid right here, in between the cornea and the lens. This fluid is discharged and replenished continuously. And as I said before, high pressure is called glaucoma. So a tonometer, for example, would be used to test for glaucoma. If that pressure in the aqueous humor is too high, then it's used to diagnose that. You can get that because either it's not discharging, this fluid isn't discharging properly, or it's being replenished at too high a rate. So you get too much fluid in there, basically. All right. Let's see, really just a couple more things. We'll wrap this up. The brain, and then we'll look at bones as well. Can I go down from here, y'all? Yeah. In the brain, we have lots of things that protect the brain. The skull, of course, protect it. We also have the meninges. Okay, so these are bones that protect the brain. The meninges, am I saying that right? Is that right? You don't know what the meninges are? Meninges? Okay. The meninges, then. These are three membranes that cover the brain. And then these meninges, you think, y'all are you guessing?
I think it's a ninja.
It doesn't matter. Okay, all right. Anyway, these three membranes contain the CSF, or the cerebral spinal fluid. You know what happens when you guess, right? What happens when you guess?
Either right or wrong.
No, people die. Right? Not in this class, but sometimes when you guess. Good enough. All right, let's see. So they contain cerebral spinal fluid. Um, this CSF cushions the brain. And it also regulates blood flow. Within your skull, you have almost a cup of CSF. So you have about 3/4 of a cup. So if you're able to pour all of it out, you'd have about this much CSF. So not a whole lot. You can have problems when you have too much or too little. If you have too much, this is called hydrocephalus. And it can lead to a high pressure, a high intracranial pressure. And too little means that your brain just isn't protected. So the brain, if there's too little CSF, the brain can bump up against the cranial bones. All right, so too little or too much of this CSF can cause issues. All right, let's see. I have a short little video here. It just shows the CSF in the brain. All right, this is where you have a leak in the CSF.
A cerebral spinal fluid leak, or CSF leak, happens when the fluid surrounding the brain and spinal cord leaks. This fluid plays a crucial role in the body because it cushions and protects the brain and spinal cord from both trauma and infection. When there's a decrease in fluid, the nerves in the brain can end up pushing directly against the skull, causing severe pain. A cerebral spinal fluid leak, or...
Okay, so just CSF, just know what it is and what it does. That it helps cushion the brain. Too little or too much is hydrocephalus, and too little can cause these issues where the brain actually bumps up against the bones in the skull. All right, and then one more thing, we'll be all done for this chapter. We're going to skip the bladder. So if you're following along in your book, we're going to skip the little section on the bladder. It wasn't going to be important. The last thing is just bones. We've already talked about this, that stress versus strain. Remember, stress was a force per unit area, and strain is the deformation due to stress. So, for example, if you weigh 180 pounds, let's do this as a clicker question, actually. So if you weigh 180 pounds and stand on one leg, what is the pressure on your knee joint? Or what is the stress? Stress and pressure are the same, except normally with pressure we're talking about fluids, but when we talk about them with solids, then we usually call it stress. So what is the stress on your knee joint? And just take a rough estimate, say the knee joint is about a 1/2 inch square. So if I weigh 180 pounds and I stand on one leg, what is the pressure? Is it A, 180, B, 360, C, 90, or D, 900? These are all in PSI, pounds per square inch. Which is it? If I weigh 180 pounds standing on one leg, so I have all that force on one leg, what is the stress on my knee joint? We're split between two answers right now, evenly between two answers. One of them is right, so ask your neighbor what they put. Try to find a neighbor that got something different. Ask them why they put that. Ask your neighbor what they put, or tell your neighbor what you put. But if you're doing this calculation, what is it? 180? What would you do? Over a half, right? 180 over 0.5, which is the same as 180 over 1 divided by 2. What does that equal to? A half will go in 180 how many times? How many times? 360, right? So what's the answer? 360, right. Okay, good. All right, so 180 over a half is equal to 360 psi. So you get a pressure or a stress on your knee joint of 360 psi. All right, good. A lot of you are putting 90. You were thinking 180 over 2 is 90, but 180 over a half is actually 360. Okay, so you just need to know stress and strain now and what they are. Now in the bones, they have a certain amount of stress that they can take and endure that strain where they'll be deformed, they'll actually bend somewhat, but once you exceed a certain amount, then they do what? They'll break, right? So you can find that as they're tabulated, what is the allowable stress for a healthy bone in our pounds per square inch. All right, I think we'll stop there.